Hello guys, this was a question which was asked in the NET 2017 December exam. The question is that 2-point charges plus Q and minus Q placed at 0.00 and D, which means that in the C axis, which I can draw here, in the C axis there is, which is the C axis, and there is a point charge in at 0 0 D, which is a 3Q plus 3Q to be exact, 3Q, and then there is another charge minus Q at point 0 0 2D. So minus Q at 0 0 2D, and which is a 2D, and this is a D, and there is an infinitely long grounded conducting sheet at the xy plane, okay, which is at the origin at the moment. Yes, this is here at the xy plane, which is infinitely long grounded conducting sheet. Okay, this is our situation, and what we need to find out is the electrostatic potential at a point Z, which is much greater than D, which means at infinity, almost infinity, a point where Z is much greater than D. You need to find the electrostatic potential of this system. Okay, that's the question that which we need to find out. So what we can do now is that we can assume, okay, there is a as a result of this existence of two charges above an infinitely long conducting sheet, okay, grounded sheet, there will be some polarization, and as a result of it there will be some charge accumulation in this conducting plate, okay. Because of these two charges minus Q and 3Q, there will be an opposite charge accumulation in the conducting plate as a result of polarization. So in order to solve this situation, we need to consider all the existing charges and their associated potential. So we know the potential of a body is equal to 1 by 4 pi epsilon 0, because of as a result of a charge is equal to sigma Q I by R I of individual for all i's. Okay, that's the potential. Now in order to consider this, we can use the method of images and solve for all existing charges. So for that, I'm going to assume that there is a charge plus Q below this below the plate, okay, below the plate, which is at the distance minus 2D downwards to the z axis, which is at minus D, okay, minus 2D, and then there is a 3Q charge, exactly minus 3Q charge at D to be exact, minus 3Q charge at D. And so our system is now complete, okay. Because of the polarization, the generated charge will be equivalent to the charge which we are considering right now, because it has to be equal. So we got our system. Now we need to find out the electrostatic potential. So electrostatic potential, total potential, can be considered as 1 by 4 pi epsilon 0 first charge, the sum of all charges and the distances. The first charge will be, okay, uh, considering the center of the dipole. If it's a dipole, here there are four charges with some separation. So considering the center point, you can assume that at this point origin, from the z to origin, we are calculating the potential. So the charge, first charge, which is minus Q, which is of a distance of z, which is from 0 to z, which is actually at the distance of z minus 2D, because this is 2D and this whole length is z. So this, the length from which the charge is situated, it will be z minus 2D. So z minus 2D, and the second charge will be 3Q by that length will be z minus D, right? Z minus D, which you guys can easily understand that. And then this will be a bit different, because it will be minus 3Q at a distance z plus D, okay. z plus d, and then there is another charge which is plus q, which is a distance z plus 2d. Okay, that's the whole potential. Now we need to evaluate the potential, and for that what we can do is that we can just solve for the equations 1 by 4 pi epsilon 0. We can combine two q of them, two q's together. You can get q into z plus 2d minus q into minus q into z plus 2d, and this was minus 2d, z minus 2d by z square minus 2d square. What I did was just cross multiplied and take the product of the denominator, and then similarly 3q into z plus d minus 3q into z minus d by z square minus d square. The same I did there. Now it's just numerical evaluation here. What we can do is we can expand it. You get qz minus 2qd minus qz minus 2qd plus by z square minus 2d square, 2d the whole square, plus 3qz plus 3qd minus 3qz plus 3qd by z square minus d square. I just expanded it, and what I will get is 4 pi epsilon 0. qz and qz will be cancelled, 3qz and 3qz will be cancelled, minus 2qz and minus 2qd will be minus 4qd by z square minus 2d square, plus 3qd and 3qd will be 6qd by z square minus d square. What I can do next, this is the only element existing. What I can do next is I can take out in the denominator I can take out minus 4qd by z square can be taken outside. What I will get is that z square into 1 minus 2d the whole square by z square plus, and I'm going to write it here, plus okay, this is the whole bracket. The bracket has to continue here also, plus 6qd by z square is taken outside, and 1 minus d square by z square. That's what you get as a whole. Now as you know, z square is much greater than d, so effectively 1 by z square will be equal to 0. Okay, because z square is much greater than d, so d square by z square will be equal to 0, because z square is much greater than d. So in that case you can write 1 minus d square by z square will be equal to 1, because the second term will be equal to 0. So 1 minus d square will be equal to 1. So you can just write v is equal to 1 by 4 pi epsilon 0 minus 4qd plus 6qd by z square into 1 minus 0, which is 1, z square into 1 minus 0, which is also 1, so it's just z square. Okay, this is the equation right there, which means v is equal to 1 by 4 pi epsilon 0 into 6qd minus 4qd is 2qd by z square. That's the answer right there. So the option which is the right one, which is option B, 2qd by z square, 2qd by z square. So we got the answer. It was an easy question. It was just mathematics there, nothing apart from that. So I hope you guys understood it very well. For more videos you get to the link t.me CSIR net physics. Okay, me CSIR net physics. Thank you for watching.